Welcome to the next unit, that is unit 4 on the control unit module, where we will be discussing the control instructions or basically the control signals and the micro instructions which are required for handling different addressing modes. So, in the last unit basically which was on control signals for complete instruction execution, which we have discussed in the last unit, we have taken some template instructions and then we have seen how different control signals are generated, and we have also considered a single bus architecture, and vis-a-vis of that we have seen in a very detailed manner that for any given instruction like fetch, decode and execute, for the complete sequence what are the different control instructions, control signals and the corresponding micro instructions required and generated. Now we are going to look at, now we are just going to extend the last unit when we will be looking at different addressing modes like immediate, direct, indirect, register indirect, some generic addressing modes, and there we will see what are the different type of control signals generated. In fact, we will be again looking at the single bus architecture. So, in fact, this unit is a smaller unit which is just an extension of the previous unit, and now we will be looking at different addressing modes in particular. So, basically as we are handling in the pedagogy sense, what is the basic unit summary? So, we will be basically looking at the different steps of instruction execution, and we will look at different addressing modes and what are the different type of control signals generated. As we have already discussed in the last unit, that basically the first 3 steps, that is step 1, step 2 and step 3 basically consist of instruction fetch. So, what happens in step 1? The program counter value is loaded into the bus, that bus basically or the program counter is loaded into memory address register, memory is given in read mode, and then actually in these 3 steps ALU actually adds a program counter value which is now in the bus with a constant value which is the next memory location, and then it is again waited to be loaded into the program counter in the next iteration. So, in the next step basically what happens, we the accumulator the ALU basically now holds the value of PC equal to PC plus 1, which we dump basically to the program counter in the second step. Also in the second step basically we wait till the memory says that I have dumped the values which or the instruction which was available in the memory location pointed by the PC to the memory data register or the memory buffer register. In step 3 basically the memory tells that it is ready, and the memory data register now has the memory data register now has the instruction which is now loaded because the memory is ready. Then actually this memory data register transfers the instruction to the instruction register via the bus. So, now the instruction register has the instruction which is to be executed. So, the first 3 steps are similar for all type of instructions because they correspond to instruction fetch. Now, from 4 onwards, depending on different addressing modes or the instruction types, they will vary. So, for example, if the instruction is a direct instruction, that is you have to read something from the read or write something from the memory location. Then in the 4th stage what is going to happen, basically you are going to take the from the instruction register the value of M which corresponds to the memory location for an instruction because it is a direct instruction. So, the value of the operand will be present in memory location M which will be specified in the instruction itself. So, in step 4 from the instruction register you will get the value of M. So, instruction may be something like off code, maybe some register R1 etc. and this memory location. So, the value of memory location will be taken from the instruction register and it will be loaded into the basically the memory address register. So, memory address register will now have the value of M, you will have to set the memory to read mode, and in the next instruction next cycle basically what happens, you will wait for the memory to be ready. So, once the memory is ready, the value of M, that is the operand in M will be loaded into the memory data register, and in the last step, that is the 6th stage, in the 6th stage you will actually transfer the value of memory data register which is now the operand to some register or to accumulator or to any other point where you want to require, where you want it to be. Basically, in fact, these 6 steps are required in case of a direct mode of instruction, direct mode of addressing, that is the value is available or the operand is available in the memory location M. But in case, say for example, if it is a indirect instruction, if it is in this case it is an indirect mode where the memory location M actually points to another memory location basically which has the operand. So, basically it is an address to another location, maybe say for example we say that we know that what do you mean by a direct instruction. So, maybe we are having maybe M is equal to 32. So, we will point to memory location number 32, inside 32 maybe the value is say 76. So, basically in the memory location whose address is 76 we are going to get the real operand. We know that this is an indirect mode of operation, so or addressing. So, in this case actually slightly the number of steps from 4 onwards is basically going to change. After 3 basically till 3 is fetch, and after that it will depend on the addressing mode or the instruction type. Like for example, if it is an immediate mode where the value is directly available in the instruction itself, basically we can just fetch. We will also see in terms of examples, the basic first 3 steps will be there, and then basically in the 4th stage basically is a very rudimentary operation, in which case you just transfer the value, basically it will be of code say R1 and maybe #7x, which is the immediate value. So in this case from up to step 3 everything will be similar. In step 4 just you transfer the value of 7 to R1, that is you are going to load the value of 7 from the instruction register to register R1 via a bus. So there will be nothing called step 5. But now if in indirect mode, the easiest way to or the shortest number of micro instructions required to execute an instruction is the immediate mode, where the operand is available in the instruction register itself. Now if it is a direct, so you require till step 6, in which case you get the operand from memory location 7. But in indirect one, you have to have 2 memory location access. So basically what happens in step 4, what you do, basically you load the value of m, because this is your instruction, you load the value of m to the from the instruction register to the memory address register. So if you look at this is your memory, so let us assume that this is your memory location m, say it has the value of say assume that the value of 72, maybe this is 72, assume m, we can assume m equal to 30, say for example. So basically this is address of the memory location address is 30, which is equal to m. So from the instruction register the value of 30 will be given to the memory address register, and the memory will be made in a read mode, and then you have to wait till the memory says that I am ready, and it is going to dump the value of 72 into the memory data register. So this is step 5. So unlike in the previous case, the 72 itself is the operand, but in this case it is the indirect mode. So in this case it will not be the, in this case it is not going to be your the operand itself, but again from 72 basically you have to get the value of 72 in the memory data register, and then you have to again look at the memory location number 72 where exactly the operand will be present. So in this case in step 4 you load the value of m, that is 30 in our example let, and it will go to the memory instruction register. From the instruction register the value of 30 will go to the memory address register, and then you have to wait. So after you wait, in step 5 what happens, it is saying that the instruction is ready to execute, sorry, the memory is ready. So whenever the memory is ready, so whenever we say that the memory is ready, that is by the WMFC signal. So once the MFC is ready, so what happens, the value of the memory, that is in our example basically, if you look at our example we are considering 70, the 70 will be dumped to the memory data register. So if it is a direct mode, we actually we can end in this step itself, or just one more step will be required to transfer the data from the memory data register to the other register or whatever you want to do. But now in this case what happens, now in this case if you look at, we require some more steps. Now again the value of this 72 which is in the memory data register has to be again loaded into the memory address register, because this 72 has to be again looked into the memory, that is this 72 will be loaded into the memory address register, and from the memory address register you will look at this second memory location, that is 72 in the example, and there you can get the operand. So very easily you can see in step 6 what happens, the memory address register data register basically in this example that is 72 will be loaded to the memory address register. So we are going a indirect search, and after that it is similar. 7 step says that the memory has to wait, because now the memory address register has the value of 72, and so whatever is available in the memory location 72 will be loaded to the memory buffer register, where you have to wait for some amount of time, which is actually step 7, and once memory is ready it will give a signal WFMC, that means the value of whatever is contained in memory location 72, that is the real operand, will be loaded into the memory data register, and then you can load it to R1. So in an indirect mode of operation you require 7 steps, in the direct mode of operation maybe you require 6 steps, in an immediate mode you just require 4 steps to do this operation. So in a summary we have discussed how different type of modes actually take different type of control instructions. That is going to be discussed elaborately with different examples in this unit. And if you look at what are the different type of basically objectives you are going to support in this in this unit. So if you look at, we have the first is a comprehension objective, in which case you will be able to explain the different addressing modes with respect to internal structure of the processor and instruction format. That is, given an instruction or a addressing mode, you will be able to tell what are the micro instructions and what are the formats, and then you will be able to design complete control steps to execute those instructions for different addressing modes like memory direct, memory indirect, register indirect, immediate, etc. with respect to a single bus architecture. So, basically the objective of this unit is that after doing the unit, you will be given a single bus architecture. Mainly you will be able to design instructions based on the or you can be able to design instructions in exact terms of the control steps or the micro operations and the control signals which will be required in different addressing modes, mainly like direct, indirect, immediate, etc. So, this is again the recap of the single bus organization. I am not going to spend more time on this. Basically already we have seen yesterday, and as I am just giving a recap because we are going to go for explaining the instruction, micro instruction and the control signals based on the single bus architecture. So, if you remember, we have a program counter, we have memory address register. In fact, this is a unidirectional bus. So, there was a slight a small error which we had again thought of it. So, just yesterday. So, we have to just this one, and this is the it's a unidirectional bus which goes to the output. So, in this case, so there is a slight this thing, and then basically we have a memory address data register which is taking the data from the memory. Then you have this ALU which is having a Y as the input from the bus, multiplexer which takes a constant as input which is required to increment the program counter. Output of the ALU is stored in a temporal register called Z. This is your register bank, instruction register, and directly going to the instruction decoder which generates the instructions, control signals for the instruction. Basically, this is the structure we have explained in details in the last unit. So, now first we are going to give an example for a immediate mode of instruction. So, just we have to just we remember that whenever we say that PC in, the value is going to the PC, and whenever we say the PC out, the value is going to the program counter to the bus and vice versa. So, first instruction mode, the most simplest one is the immediate mode. So, we are just saying load R132. That means the value of 32 constant will be loaded to R1, and we are assuming that this instruction takes a single word. So, in this case the PC has to be incremented by 1. So, what are the steps? So, the first step, if you look, it will be program counter will be the output, it will go to memory address in. So, what does it mean? Already we have discussed with the figure in the last class. So, this I am going to keep a bit brief. So, PC out and memory register address in. That means what? The output of the program counter will be loaded to the memory address. It will be in a read mode, select will be 0, add and Z in. So, up to this PC out, memory register address in and read. This corresponds to the fetch part. Select 0, that means you are going to add the constant to the program counter, and the output will be of the ALU will be going to register Z. This corresponds to increment of the PC, which you have already seen in details in the last unit. Then in the second state, Z out, that means the output of the ALU, that is Z, which is now equal to PC plus constant, will be going to PC in. That means the output, that is PC equal to PC plus constant, will be loaded into the PC via a bus, and we are waiting till the memory sends the signal that I am ready. So, once it is ready, the output of the memory data register, which now has the instruction that is equal to load R132, will be loaded into the instruction register. So, this up to these 3 stages, as we have already seen, basically corresponds to fetch. Now, as it is an immediate instruction, we just require just one more control part, that is in the instruction register we now have the value called load R132. So, that value of 32 will has to be taken from the instruction register and dumped into register 1. So, very obvious signal will be instruction register R out and R1 in. That is as simple as taking this step. If you look at it, now basically you have loaded your instruction, that is some load R132. This is already is present in your instruction register. So, this part has to be abstracted, that is nothing but equal to IR out, and it has to be loaded in R1. So, this is maybe this register is called R1. So, it will be R1 in and IR. So, that is done basically. So, it will give the value. So, there are basically 3 steps involved in this case, extremely simple, that is fetch, and after this just you require one stage, in which case the value of the instruction register immediate part will go over here. So, basically for an immediate mode we just have 4 micro instructions, and your actually 4 micro instructions and your job is done. First 3 micro instructions or sequence of control, fetch, and last one you take the value of the operand from the instruction register and dump it into the respective register. Then next is the direct mode. Direct mode already also we have discussed yesterday, but in this case we are going to just see a comparison that what is the more complexity involved. So, in this case we will see that we require 6 stages or 6 micro instruction in sequence. So, the first 3 like program counter value to memory address, read, select and increment of PC, and this 3 basically and MDR out to register in. These 3 instruction or 3 controls basically corresponds to instruction fetch. So now once the instruction has been fetched, so you will have the value add R1 M. This will be in your register, which is your actually nothing but your instruction register. So this one will be available in your instruction register. So from here I have to extract the value of M and I have to put it into the memory address, so that I can get the operand from there. So what I am doing, I am taking instruction register value out and I am making MAR in. So basically it will take the value of M, which is your memory location, basically to your. So what will happen? So in this 4th stage basically what is going to happen, you are going to take the value of M and you are dumping into the memory address register, so that you can read the value of the operand. So if you look at it in the bus architecture, so what it's simply what we are doing in the 4th stage, the instruction value is say add or load whatever R1 into memory location 32. So this 32 I am taking it from the instruction register by IR out and I am putting into the memory address register, so that the memory location value 32 whatever is in this can be it will come as an operand and it will go to register R1 or wherever you want to dump. That is actually you want to read this value. So this value of 32 from the IR is going to dump to memory address register. So IR out, memory address register in. So that is what I am doing. Make the memory to a read mode. In 5th stage, you have to wait till everything is ready. So once it is ready, that means the memory data register now has the value of this instruction add R1 or M or load R1 M, whatever may be the case, but it is a direct mode of addressing. So now after this one, basically you are having the value of after the 4th stage and the 5th stage, when memory has been read. So the value present in memory location M is now dumped to basically your memory buffer register. That is done. After 5 says that the memory reading is complete. After that what you are going to do? You are going to in this case add. So in my case, in this case specific example, you are going to add. Had it been load, we could have just transferred the value of memory buffer register to the corresponding register R1. So had the instruction been load R1 M, so we could have done very simply that after this in 6th stage we could have made memory data register out and we could have made R1 in, but in this case instead of load it is an add. So I have to do an add operation. So again slightly the number of steps will be different or the control sequence will be different. So what I have to do? First thing is that I have to, let me look at this structure again. So now if you look at it, so now the value of M has been loaded or the operand which is present in M is present over here. The content of M is available over here. So now the instruction was add R1 and it is M. So the content of M basically is now in the memory data register. So now I have to add it. So for that I require the ALU. So I have to first one control instruction will be enabling the add. Secondly, the value of M has to be put in the value of Y, because at the next stage I am going to use the value of R1 which I will directly feed over this operand so that I can add. So now in this step what you are going to do? You are going to take the value of MDR out and you are going to dump it at Y. So the value of M will be dumped at Y. I will make add equal to 1 and I will make the select equal to 1, so that the value of M via Y can be coming to the ALU. So you just see this step. So it is saying memory data register out, Y in, so that I can put the value of memory data register, that is M or the content of M into Y, select equal to 1 and add. So that constant is now not required. The value of MDR, that is the content of M, will be in Y and it will be added. Next basically the adding is done. Sorry, the adding is not yet done. Basically what I have to do is that in next stage I have to make R out. So as I already told you, this is the state R out Z in. That means now one operand to the ALU, this is one operand to the ALU directly coming from Y, that is your content of M, and this is your bus, and you are making this is R out, R1, you are making R1 out. So the value of R1 is the second operand to the ALU, and you are making it as add mode, fine, and the output of this is going to the register called Z. So I am making that Z in. So in this stage basically your adding is done. One operand from memory location M was stored in Y and is one operand to the ALU versus via Y, and the other operand is from register R1 which I am directly taking via the bus, this is your single bus, by making R1 out. So Y equal to, so now the ALU is having the value Y which is actually the content of M plus register R1. So it is stored in Z in. Next stage is very simple. Basically what happens in the next stage, again I have to write the value of the sum back to R1. So, what I am going to do now, I will make R out. So, sorry, I am going to make Z out. So, if I make Z out, the value of Y plus R1, that is the content of Y plus register R1 will be dumped to the bus, and I will make R1 in. So, if I make R1 in, so the value will be fed from Z out to register R1 and your job is done, which is basically step 8. So, if you see in a direct mode, had it been just the load instruction, that is load R1 accumulator, we could have done in 6 stages, but at this an add instruction, so you require 8 stages in the direct mode. So, depending on the type of instruction, that is the job or the functionality of the instruction, as well as the addressing mode, the number of steps and sequences get changed. Last 2 steps basically again let us quickly look at in this example. So, basically till now what has been done? So, the Y is over here, the R1 via R out is here and Z in is there. So, the value of R1 plus the value of content of M via Y is now in Z in. Last stage is basically we make the Z out. So, the value of Z is dumped over here and it is going to R1. So, we are going to make R1 in. So, in that case the value of Z by virtue of signal Z out will be dumped to register R1. So, Z out equal to 1 and R in equal to 1 will dump the value of Y, that is actually the content of M plus content of R1 into R1 itself. So, that is the basic path. So, this is what has been explained. Now, we will go to the another mode which is more complex in nature, which is the indirect mode. By indirect mode already we mean that whenever I see indirect mode of M, that means the say this is the memory this is the memory, here is M as the address of M, here there may be some address is called X is some content over here, then again you have to look at the content in X and basically this is your operand. This is what is the idea, we all know about it. So, if you now look at basically your first 3 stages. So, first 3 stages as I already were discussing like PC out, MR in, and these 3 control stages basically are only for fetching the instruction. Next one is what I have to do. So, this is the instruction load R1 into memory from indirect memory location, that is the content of M. You have to again go to that memory location and there you will get the operand, it has to be loaded to R1. That is, we say that load the content of memory location M1 to register R1, where M1 is specified in the memory location M, that is indirect, and we assume that the length is 1. So, the next stage is IR out, memory register in and read. So, in fact, we are fetching the basically, so what we are doing here. So, now the after executing the third instruction, the third control step, register instruction register IR is having the value of load R1 M. So, in the fourth stage what I am going to do, I am going to take the value of M and I am going to feed it into the memory address register, so that you can read the value of memory location M, that is X in this example. So, IR out, that is you are going to take the value of M and dump it into the memory register address register, so that now I can read the value of X. Of course, in stage 5 we have to wait till everything is ready. So, once it is ready, basically we know that the value of memory location M, that is X in the example, is now loaded into the memory data register. Now, interestingly, for all cases what we have seen, for most of the cases after the memory data out, if it is a direct instruction, we generally take this memory data out from the memory buffer register. We actually say IR in if it is a fetch, or sometimes we call R1 in that way. That means the operand that is present over here, the X, we are directly loading at some place or we are directly using it as an instruction. But in this case it is very interesting that the memory data out will be fed to the memory address register in. Basically that means what? I am going to take this value of X and I am again dumping it to the memory address register, because exact value will be found out in memory location X. So, if you quickly look at what it happens in the bus, it will be more clear. So, look at the bus. So, many times you have to refer to this diagram. So, we will recollect the phase we are in. So, basically we are in this stage when say load R1. So, if you just recall, the instruction is something like say load R1 indirect M, and your M we are having something like this is M, this is X, this is your memory location X, and this is actually exact content. So, now your instruction register basically has load R1 M, that is already there. Now, what we are doing? So, now we are making IR out and we are loading the memory address register with M. So, this is done. So, now it is done means now the content of memory location, that is X, will be given into the memory data register after you have to wait for MFC. Now, what happened? Now, this content X generally is used by some of the registers. If it is a data or if it is an instruction, it will go to IR. But in this case, interestingly, what is going to happen? This X will be again going to fed back to the memory address register. So, in this case, now it will be an X. So, if it is an x, the content we can say that now the content is L. So, that content will again come here and which is actually your real operand. So, in next stage what we do? We say memory data register out and memory address register in. So, that the value of x will be fed to the memory address register. Now, the memory buffer register after a wait will give the exact value which is present in memory location, which is your exact data. So, which will come to the memory data register and then you can load it to your R1 or wherever by a simple signal sequence, that is MDR out register 1 in. So, that is what is happening, right. So, in this case you read the instruction, then you read the wait for some time the signal, that is add, so load R1 M, this instruction is already loaded into the memory, then you take in the sequence you memory data register out and basically you are going it in memory in. That is a very important stage over here, that is you are going to take the value of content of M which is was x and you are dumping it to the memory address register. Next you wait for some amount of time and then in this case now exactly you are going to have the operand which is present in the memory location x, that the content we are assuming L for the time being will be taken from MDR and it will be dumped to register R1. So, in two indirect stage, in R1 we have got the exact operand, that was basically first the content M which was x, now this is x and the exact content L which will be actually dumped into R1. So, in the indirect mode we can get the values. So, now again another mode we are taking which is called register indirect. In this case it was a memory indirect, it is a register indirect, that you have to go to the register and the content of the register will also contain the location of a memory where the data will be present. Like for example, load the content of memory location M to register R1 where M is specified in register R1, that is say there is a register, load the content of memory location M to R1, so this should be R2. So, load the content of memory location M to register R1 where M is specified in R2. So, R2 will have some value M. So, if it is your memory, so this is your value of M. So, this is your R2. So, exact value of the operand address will be found in R2. So, R2 will have the value of M. M will have to be fetched into the looked into the memory. This exact value say L will be dumped to R1. That is what is the register indirect mode that we are going to now do. So, as already discussed many times that the first three stages are basically for your basic operation of loading the instruction, fetching the instruction. Then what we do? Then we say R2 out and memory address register in. So, now in this case it is interesting. So, what happened? If you look at R2, so R2 basically is a register where the exact address of the data is present. So, in this case if you see, so what I am trying to do, so if you look at, so your instruction that R2 register, basically this is your register R2, it has the value of M. So, that is your actually memory location address. So, this one you have to feed it directly to the memory address register. So, once you give the value of M which is the content of R to the memory address register, it will get the value L after a reading. So, you will do register R2 from memory address in. From R2 actually you are going to dump the value of the memory address in, because it will have the value of L. So, you note in this case we are not actually reading the value to memory address register from the instruction register. For all other cases if you look, so if you had some instruction like as I told you, like say load R1 say M. So, what we used to do? We used to load the value of M from the instruction register directly to memory address register. But in register indirect mode if you observe, what we are doing? We are directly taking the value of R2 and we are loading it to the memory address in. So, actually the instruction register when it decodes, it finds that it is an indirect addressing mode. So, in that case the role of the instruction register is to directly hand over all the stuffs to register R2 and not get involved in the picture. But if it is a direct mode or an indirect mode not involving a register, so in this case the instruction register value, the M, has to be directly basically loaded into the memory address register. So, in this case the instruction the decoder will generate such a signal, so that instead of R2 out it will be instruction register out, that is it will take the value of M and dump it into the memory register in. It is a memory direct or memory indirect. But if when the instruction register finds that basically now the instruction is involved with registers only and no memory is in picture, so directly R2, the content of R2 will be directly loaded to the memory address register. That means basically R2 the content M will load to the memory address register. After that it is very simple, you have to wait for some amount of time, and in that case basically so once it is done, the memory data you have already given it the address of M to the memory address register, you have to wait for some amount of time, and then this L will come to the memory data register or the memory buffer register, and it is done, then just you have to load it into R2. So, you have to wait for some amount of time. After the memory data register, you are going to dump it to RU. So, you can see, sorry, it is actually in this case it should be, I am just a mistake, it should be basically register indirect mode, register indirect. Just a copy problem. So, in this case if you can see, so your indirect mode, if the memory indirect mode, you require 8 stages to do it, but if in your register indirect, basically you can solve it in 6 steps of time. So, basically register indirect is a more faster mode compared to a or less number of steps required to a memory access, because in this case you just require one access, but in the previous case you require 2 memory access, and in fact also it depends on whether you want to load or you want to add, and all those problems are there. So, depending on different type of addressing modes, the sequence of control and the number of steps will all differ. So, this unit basically gave you a spectrum of different type of addressing modes and with different functionality like load and add, and we have shown what are the sequence of control instructions required or the micro instruction, and how a complete instruction can be controlled in with the respect to the control signals. That is basically which we have covered. So, we have taken immediate mode, direct mode, indirect mode, register indirect mode, register mode, and so forth. So, which gave you a wide spectrum of designing instruction set in terms of basically your control signals, given a single bus architecture as well as different type of addressing modes under consideration. So, basically as I told you, this is quite small module. So, we come to that, and then we have a very simple question like draw the diagram of a CPU with single bus architecture and write different type of instructions with immediate addressing, indirect addressing, displacement addressing, and some other addressing modes, and try to design this try to express how the instructions will execute in terms of control steps and what are the control signals for that. If you are able to answer this, of course, the 2 objectives of this course like explain the addressing mode with respect to internal structure of the processor and instruction format and the control instructions, and design the complete control steps to execute instruction that involve different addressing modes get satisfied. So, once you after doing this unit, you will be able to solve this problem and you will be able to meet these objectives. So, with this basically we come to end of this unit, and in the next unit what we will be looking at, we will be looking at more sophisticated type of instruction like a jump instruction, function call, etc. So, which will require slight more integrated details. Thank you.